Okay, let's continue to talk about statistics that we use in CSD. So how do we decide what statistic to use? Well, it really depends on what we're measuring in our dependent variable. So it depends on the level of measurement. Remember we talked about those levels of measurement, nominal, ordinal, interval, and ratio. So it depends on that and on the experimental design. So in CSD, we typically use a t-test or an ANOVA for our continuous data. So that's the interval or ratio. And we use that to test differences between groups of research participants. We use chi-squared. See, this is indicating chi-squared when one of the variables are categorical in nature. And so all of our statistical analyses that we do, they're reported in the results section of a manuscript, of a journal article. Okay, so a t-test. A t-test assumes that the data is more or less normally distributed, that is, the variance is equal, and that you're pulling from a random sample. Okay, so if you pull from a random sample, then your two samples are normally distributed. So we do a t-test to compare data from two groups of research participants. Okay, this is really important. If you have two groups, let's say we have our, let's go back to our example of the undergrads and grads watching Netflix. If we want to determine the difference between those two groups, we would do a t-test. Now there's two different types of t-test. There's a between subjects design t-test, and it's also called an independent t-test. And then there's a within subjects design, and that's called a paired t-test. So a independent t-test, this is when you're looking at between subjects. So the subjects are not getting, they don't have scores on two different things. So for example, with our Netflix watching, those would be two separate groups. We would get the amount of time that the undergrads watched and the amount of time that the graduates watched. And those are independent between subjects. And within subjects design, this is where the research participants, let's say we have a group of people take a test at the beginning of the semester, and we get their scores on that test, and then at the end of the semester we give them a test to test their knowledge on how much research they learned in the class, and we get their scores on the same test. And we want to compare pre and post how these same people did. This would be a within subjects design or a paired t-test, because it's the same participants that are getting a score the first time and the second time. Okay, so typically we use t-tests when we have a small sample set. So if we have research participants about under 30. So what a t-test does is it takes the mean of one group, the mean of the second group, and divide it by the standard error of difference, which is a measure of variability of the scores attributed to error. So I'm not going to ask you about how to calculate it or anything like that. What I really want you to know about t-test is that it's comparing data from two groups, and it can be either between or within. Okay, let's just talk about degrees of freedom for just a minute. Degrees of freedom are related to sample size. So in t-test, the degrees of freedom are the sum of the persons in both groups minus 2. Okay, so if we see something written out in the results section that looks like this, t parentheses 532 equals, minus 1.70, we can look at this number here, and that's indicating the degrees of freedom, and we can tell how many participants were in the study. So for this one, we have there's 534 people in this study, because it's the sum of the persons in both groups minus 2, so we'll add back 2. So it's 534 people. Now, we're going to talk about ANOVAs in just a minute. And the degrees of freedom are the number of groups minus 1. So let's say we have 3 groups of people we're looking at their data. So 3 groups minus 1 is 2 in this example, comma, the sum of the persons in the groups minus 1. So with all of the groups, there's 180 people. 180 minus 1. Okay, and then in a chi-square, the degrees of freedom in a 2 by 2 chi-square is just 1. So I'll keep talking about degrees of freedom when we talk about each type. So let's see an example of a t-test statistic in CSD. Okay, so this researcher examined African American and Caucasian children's scores on the Peabody Picture Vocabulary Test, and they asked, is there a difference in the scores of African American and Caucasian students on the PPVT? Okay, so that was their question. So what they found was on the PPVT, the African American children scored slightly lower. So they have the mean of how they scored and their standard deviation than the European American children, and they have their mean and standard deviation. However, an independent t-test, they did an independent t-test because these are 2 different groups, showed that the 2 groups did not differ significantly on the PPV-3 3 mean scores. And so when you look at these, this is how it's going to be written out in a results section. T, and then it has the degrees of freedom, so we can tell how many participants they had, equals, and this is the T number, and then this is giving us the p-value. So remember the p-value, what do we really want to look for? We want to look for a p-value that's less than 0.05. So this is greater than 0.05. So what are we going to do? Are we going to accept or reject the null hypothesis? So we are going to accept the null hypothesis because we are going to say that there is no difference between the 2 groups. So the means show us that they're slightly different, but they're not significantly different, statistically significantly different. Okay, so this p-value is telling us the probability that we're committing a type 1 error. So we have 9 chances in 100 that we're committing a type 1 error, and that's too high of a risk. So it's too high, 9 in 100 is too high of a risk. So we're going to accept the null hypothesis, and we're going to say there's no difference between these 2 groups. A 2-tailed analysis means that the hypothesis was non-directional. So we just know that it was not, that didn't state which way it would go, which group would do better. Okay, so in another study, they examined African American and Caucasian children's scores on the preschool language scale. They asked, is there a difference in the scores of African American children and Caucasian children on the preschool language scale 3? And so the results were the African American children, here's their mean and standard deviation. Here's the Caucasian children's mean and standard deviation. And here are the statistical findings. Okay, so what are the, what's the degrees of freedom? So you should tell me 749 is the degrees of freedom. Now, based on the degrees of freedom, how many children were in the study? You should get 751 because it's the total number minus 2. What is the probability value or the alpha level? So the alpha level here is p equals 0.77. Do we accept or reject the null hypothesis? You all should say that we accept the null hypothesis, meaning that there is no difference, no statistically significant difference between these two groups, because this number is much higher than 0.05. Okay, so here's how it would be written up. An independent t-test indicated that the PLS-3 total scores of the African American children were not significantly different from those of the European American children from similar socioeconomic backgrounds. And then it's got the t, the degrees of freedom, the t-number, and the p-value. Now, all of this information, you would be getting all of this information from a printout from some statistical software program. So something like SPSS is one that we use a lot. And once you run your t-test analysis on this software program, you will find these numbers on here and plug them in. I'm not going to ask you to do that, but I just want you to realize that's where those numbers are coming from. And so when you read this, this is what it means, and you're looking at the p-value to make some decision. Okay, an ANOVA or an F statistic, this is where you have some general assumptions. So this is where you have interval or ratio data, and so the data are continuously measured. The research participants are randomly sampled, and the data are sampled from a normally distributed population. And so what the whole goal is with an ANOVA or an F statistic is that you're comparing more than two groups. So with a t-test, you're comparing two groups to see if there's differences. With an ANOVA, you're comparing more than two groups. Okay, so the goal here is to determine the probability that the means of groups of scores deviate from one another by sampling error alone. Okay, so what an F statistic actually does is it's looking at the effect over the error to look at within group variability. But again, I'm not going to ask you about that on the exam. Okay, we talk about ANOVAs in terms of different groups. So a one-way ANOVA, this would be where we have one independent variable with several levels. A two-way ANOVA is a study that has two independent variables with several levels, or a three-way ANOVA is three independent variables with several levels. So complex ANOVAs, they allow for examination of variable interaction as well as main effects. So interaction can be interpreted as an effect is modified by another effect. So let's look at an example of a one-way ANOVA. Okay, a one-way ANOVA has one independent variable with more than two levels. So if we're looking at language skill, and we're looking at poor language skills, average, and excellent, this is one independent variable, language skill, and then there are three levels. Okay, so this is how you'd see it written up. There is a significant effect of language skills, so it's giving you the number of independent of levels, and it's giving you the number of participants equals 1.36, and p is less than 0.001. The children with poor language skills, here's their mean and standard deviation, were significantly worse than the children with average language skills, and here's their mean and standard deviation, and children with excelled language skills. Okay, so let me go back for just a second. Now, when we look at the degrees of freedom in an F test, the degrees of freedom are the number of groups minus 1, comma, the number of persons in the group minus 1.